Now let's learn some differentiation rules that help us do our derivative solutions as we move forward as soon as possible. So those rules help us try to come up with a solution of a certain problem or certain example as fast as possible, because those rules are built based on a certain practices and proofs that show this kind of rule works every time you use it, instead of going all the time through a detailed old way solution. Then you can just only use that kind of rule which is pre-approved by scientists to be used within your solutions. So first rule, you have a constant rule, which means any constant that you need to do a derivative for, that derivative for that exact constant equals 0. So if your function f of x is c, constant 1, 2, 3, 4, minus 1, minus 5, minus 8, if you do a derivative for that number, then your derivative will be 0. That's something to keep in mind. Secondly, we have constant multiple rules. So if you have a function g of x equals a constant multiplied by another function f of x, then in this way the derivative of g prime of x is that constant multiplied by the derivative of the function f of x. We will take examples on those and learn how it is happening in actual example solution. Then we have the power rule. If you have f of x equal x to the power of n, then the f prime of x is, you jump the n to the side as a factor of the x. So you have n multiplied by x to the power of n minus 1. So what you do, if you have f of x equal x to the power of 2, which is n in this case, then the derivative of x to the power of 2, or x squared, is equal to 2 multiplied by x to the power of 2 minus 1, which is 2x. Now the rule of sum and differences, if you have a function h of x is a combination of the addition or subtraction of two functions, and you need to do the derivative of that function, what you do, if h of x equals f of x and another function g of x, you need to add them or subtract them. Then the h prime equals the f of prime of x plus or minus g prime of x. So the derivation can be distributed on the contained functions in this case. The product rule, if you have h of x equal two functions multiplied by each other, first function f of x, other function g of x, then the h prime, or the derivative of the function h of x, equals the derivative of the first function, which is f of x, so you give it f prime of x, multiplied by the second function as it is without derivative, plus the derivative of the second function, which is g prime of x, multiplied by the first function without derivative, if that makes sense. So you have a function, have that function having two functions within it. You want to do the derivative for that function, then the derivative of the first multiplied by the second plus the derivative of the second multiplied by the first. That's what this is telling, and we will see that in examples. Now the quotient rule, I call it the division rule. There's a product rule that we learned here when you have a multiplication. So you can call this a multiplication rule or a product rule. And there's a quotient rule, which is the division rule. If you have a function h of x consisting of two functions divided by each other, f of x and g of x, then h prime of x equals the denominator derivative multiplied by the denominator without derivative minus the denominator multiplied by the denominator derivative over the denominator squared. So you have f of x over g of x. So you take the derivative of the f of x multiplied by g of x as it is, minus, that's all in denominator over here, minus the prime of g of x multiplied by f of x as it is over g of x as it is squared. The chain rule, if you have h of x equal f as a function of another function which is g of x, then the derivative h prime of x equals the f prime of g of x multiplied by the g prime of x. I know that's ridiculous. H of x equals f of g of x. Like, functions are being constructed inside each other, but you will have a better sense of that as we're having example. Keep that in mind, and let's have a little more derivative rules. Then we jump right away into our examples. Now for the trigonometry derivatives, f of x is sine of x. Then what's the f prime of x? That's something you need to save in mind or keep it on a side paper to use it whenever needed. So it's a good practice to have a table of derivatives for certain functions, like the trigonometric functions have a certain derivative. Those derivatives are being approved, as I told you, by scientists and shown that sine of x prime equals cosine of x. This is how it is. If you need the explanation of how did the scientist came up with the derivative of sine of x to equal cosine of x, can go back to the references, and probably that would make more sense for you. But as moving forward, to get a fast solution for your problems or examples, then you need to have that handy. Derivative of sine of x is cosine of x. Derivative of cosine of x is minus sine of x. Derivative of tan of x is secant squared of x. Derivative of secant of x is secant x multiplied by tan of x. Derivative of cotan of x minus secant squared of x. Cosecant of x derivative equals minus cosecant multiplied by cotan of x. And what we're saying here, f prime is exactly meaning d over dx. So when you have the f prime equals, if the f of x equals sine of x, what's the f prime of x? You're saying d sine of x over dx. That's exactly what it means. In this case, cosine of x, and so on. Just I wanted to show you that there's a different representation when you have a sine of x or other function other than f prime. You know, we can use sometimes y prime, we can use f prime, we can use dy over dx as a derivative representation. But sometimes we use the function right away. D sine of x over dx means what is the f prime of x where that function equals sine of x. That will give you cosine of x, and so on. Exponential derivative, if you have a function equals a to the power of x, then the f prime equals the ln of a multiplied by a of x. If you have e to the power of x, what is the derivative of that? Nothing changed. It is e to the power of x. Sometimes you have a constant here. In this case, it's 1. If you have a to the power of g of x, so there's a constant to the power of a function, then in this case, the f prime ln the a multiplied by a to the power of gx multiplied by g prime of x. E to the power of gx, the prime for that equals e to the power of gx multiplied by g prime of x. Logarithmic derivatives, the logarithm of a of x, if you derive that, the derivative for that equals 1 over ln of a multiplied by x. If you have f of x as ln of x, then the f prime is 1 over x. The log of a to the g of x, in this case f prime of x, equals g prime of x over ln of a multiplied by g of x. F of x equal ln the g of x, then the f prime equals g prime of x over gx. I know those may sound confusing for you. That's totally normal. Until you see the examples, then everything will make sense for you.